So to introduce myself, my name is Mihailo Milenkovic. I'm working in Deploy as an Android firmware engineer, and I chose this topic to bring you closer the experience of building your own custom device. Basically, I have worked on one custom Android device in this company, and in the end, I will show you a little bit about that device. You could look it in person. And my idea of everything is just to explain you what is the road to, if you decide to go that road, to build your own device, either for your own project or something that you need, or maybe some of you, you'll never know, end up in creating a device that will be used by general people and maybe globally. So I will speak a little bit about custom hardware, about what is the architecture of Android on a custom hardware, what you need to prepare, to develop, to have a successful device that will work. So let's switch to just a brief overview of the presentation. Little intro about devices and let's call it IoT. Everybody knows what IoT is, Internet of Things. I will speak about hardware, what you need of the hardware to make your own device, how would you approach it, what's the best way, what are the worst ways to go, and what can you find as difficulties while going that way. Then I'll cover a little bit about the bootloader, the kernel, and the Android, what is basically the architecture of the device and what you need to prepare. And in the end, I'll explain a little bit about the product is called Ray, and it's a custom device. And I also brought, for the very end, I brought one of development boards, so you can take a look of it. I will show you a little bit, and so you can get to know how it looks in real life. Okay, so as we look for today versus the 10 years ago, the Internet of Things is getting more and more the part of our everyday life. So now you have the devices like in fridges, in washing machines, in as a home automation device in your home. So it's getting day by day, it's getting out into our real lives, and the need to create a complex device, not just a basic something with a button or something like that, but a complex device that will interact with the user is getting increased. So even not the big guys, but the usual everyday developers got a need to create something like that. Okay, so probably most of you, I don't know if you had any experience with Android and with the devices, but even I, let's say 5 years ago, I thought, okay, if I would go to create my own device, wow, how would I do it? It's rocket science. I mean, I don't know how to do it. But basically, this is not the case. So creating your own device, creating custom device is not only for big players like Google, I don't know, Samsung, Apple or something, but it's also for you. So you can do it, and it's not so difficult. The one question that you should ask yourself in the very beginning, so if you have some idea, some project or something, is do I need a custom device? So this is one of the first questions that you should decide, because here the ways you will go will split. So when you spec your project and you see what are your needs, you have to see if there is something else on the market that already exists and that you can use for your project. So if there is, I would really recommend you go that way, because creating a custom device is a very, very difficult path. It's not for the big guys. You can also do it, but you will have to invest a lot of time and a lot of effort, money, whatever way you decide to do it. So when you ask yourself and you decide, okay, there is no device that will suit my needs, and you decide to go the custom ways to make it your own, like you plan it. You should choose, for example, when you spec the hardware and everything, you should choose what OS I'm going to run. So that would be, for example, the second question you should ask yourself. And I would here like to explain why should you use Android. So a lot of you are using probably Android or Apple iOS. The thing is that on the market, you have several ways for your hardware, what operating system to run. So you have some real-time OSs embedded without UI. You have some also OSs that can allow you creating complex UI. But as an Android is becoming a larger and larger platform day by day, probably if you have a need for user interaction, complex UI and UX with the users, you should choose Android. One of the reasons for that is the Android is first open source. So, for example, you probably, I don't know, maybe 50-50 or how much people here, maybe somebody likes iOS and Apple, somebody likes Android. It's always two groups, but for the iOS and for Apple, you know that it's not open and you cannot use it. So the first thing that draws you to Android is an open source. Another thing is that you have a lot of apps on the market. So if you decide that your device will use some other apps, not only your own, the best platform would be Android because you can connect to the market or you can use other applications without the market if you can get them and install them legally, I speak. And so yes, this is good. And sorry for not mentioning this in the beginning, but if you have any questions, please ask. I have time for Q&A in the end, but it's better to ask it immediately while it's fresh, so I can explain. So Ubuntu is another OS that you can run and that went embedded. So it's not only for the computers, but you can run them. There was also, if I remember, a Ubuntu phone project, so the mobile phone with Ubuntu OS. The thing is, the biggest disadvantage of that is the thing I mentioned, and it's marketplace. So there is not a lot of apps on Android, on Ubuntu, sorry. They are probably growing. I didn't look at Ubuntu OS recently, but the market with the apps and with the diversity of apps is a lot bigger on Android. So you can go Ubuntu or either different way, like some real-time OSs and some smaller OSs. It depends on your project specs. I will show you in the end of the presentation the Ray device, and you will see, for example, why it was Android, probably. But as you mentioned, you can also go Ubuntu. For now, the topic is developing Android device. So, okay. So we covered the topic. Why should you use Android? Now let's look how the general architecture of Android device looks. So you have your device, your hardware, and it needs to run something. So on the top of the hardware, you have to have something that will boot your OS. In the case of Android, you have a bootloader. Of course, on PC and everything else, you have a bootloader. So something needs to boot your OS. Next, from the bootloader, when you get booting, it needs to boot your OS. So in this case, in the Android case, it will be the kernel of Android. It's a Linux kernel, and probably a lot of you knows that. And when the kernel boots, it will boot Android. So in this talk, I thought about the presentation. So just to go back a little bit, when I thought about this presentation and speaking on walks, my first idea was to talk to you a little bit technically. So to make a technical presentation and to show you how to do things. And then I realized like it's 45 minutes and I could not scratch even the surface of some topic. So I changed my mind, and basically I'm going to talk about several topics, generally in brief, just so you can see what you need to do and what topics and what sections you need to cover when going this way. Okay, let's talk about hardware. So first, you should try to design your hardware. So you decided, okay, I'm going to create my device. So what should I use? For example, what should my hardware be? What are the specs and everything? So my advice for this is try to specify the hardware based on your project. People can go different way and say, for example, okay, I will look today's components like, for example, I don't know, Samsung S7 phones or something like that. What are their hardware specs? And I will use that the same. But you can end up with a pretty high cost of production of your device. And the thing is, when you want to either make it some project of your own, or you want to go to the public and to sell the device to the users, you want the production to cost as low as possible, because you will spec your device cost for some price, and in that price a lot of things will be included, like the production cost of the device, the development, the guys and everything, infrastructure, marketing, a lot of stuff. So in general case, maximum that you should shoot for the cost of production of the device should be 50% of the price that you're selling. So, and that is even alarming, like 50%, you probably won't get your money back with the 50%. So you must target lower, like 30, or as low as possible you can. So to do that, best thing is, okay, I will look at my project idea, what it's going to do, and I will tell myself, okay, it needs to do that. So for this, I need this kind of hardware. We're not going to talk about the real hardware. I mean, the processors and the speed. So that's on you to decide and to find out. But basically, do not go like, okay, I don't mind a little bit faster CPU. I don't mind a little bit more RAM. It's a good thing to think about the future. But until you get out, until you create your device or sell it, try to have as low production cost as possible. So if you want in the future to run something complex, maybe you should think in the way, let's make another version of the device, like number 2 or whatever.
Do you actually test that using some simulators, or it's just
I will cover that topic. That is something that I'll also mention, but basically, as you have a big market of Android devices, you can maybe make some proof of concept and run it on some existing device. For example, some mobile phone that you have your own or from somebody else, and you can run that proof of concept to see is the hardware enough for that, or should I need something faster, bigger, whatever. So regarding this topic that I mentioned, you should try to consider using, as I also mentioned before, using some existing platform. In this way, you will try to find if some of the manufacturers are supplying with the platform that you need, with the hardware that you need, all the specs that you need, and if you're able to find something, a development board or another device that with a company which you can collaborate and which are not so closed and they can open to you and want to collaborate, the best way would to be to use an existing platform, as again, creating your own will spend you a lot of time, like with the hardware design, with the proofing, making a prototype, trying it, and then iterations of changes. This is bad, that is bad, let's try this. So you will lose a lot of time creating your own platform from scratch, but if nothing suits your needs, that's the way to do it. And while you're looking at the hardware and everything and you're busy on that, you should consider even starting the development of the applications that will run your project or whatever, even before getting the hardware. Because getting the final version of the hardware can last like 6 months, 1 year. It depends on the complexity of your device. And you, as I mentioned, you will have a lot of iterations, and you should not take it for granted. Like, okay, I will finish my hardware and then I will switch to the development. But you should start the development of applications right away. To do that, you can use the development board from some supplier that you probably decided to make your device on that platform, and you can develop your applications and other parts of your project, like the backend and everything. So you can do it on the development board and try everything else. And then when you get the final hardware, you will move to the custom hardware. You will test if everything works the same as on the development board and everything else. So to give you the insight of what you can use and to get to the concrete things, if you decide of going, okay, let's make an Android device, let's make something custom, the starting point for you could be several platforms. One of the platform is from the Freescale. It's called now NXP because NXP bought Freescale. But one of the platform is developed by Freescale, and the processor is called IMX, and they have a lot of development boards available on the market, even the low-cost one and the pricey one. So you can decide going that way and using the IMX as your base, as we also done this on Ray, we developed. You can have, for example, the Saber board that is, just to give you the info so that you know how much is it in the price thing, it's something like $250, I think, just the basic board without the LCD. But I also brought one of the NXP or the Freescale boards that I will show you in the end a little bit. That is a complete platform. You have the LCD, you have a lot of components like LAN connector, GPS, you have the slot for the SIM card so you can plug in the mobile module so that you have a mobile connectivity. It has audio, it has buttons. So on a development board you usually have a lot of peripherals, and you will probably be able to do everything on the development board that you want. If not, there are always some expansion ports, protocols, which you can connect your custom thing. In our case, we were building a remote that I will show you later, and it needs infrared diodes. So here you do not have infrared diodes, but you can plug them easily and get them working. I can say that the Freescale, or now NXP, built a really good platform, the IMX. As I remember, we were using IMX 6, and now you have IMX 7 platform, and it's getting better and better day by day. So if you choose to go this way, you will not regret. It's a complete platform. Everything works. You have a lot of protocols. You have a lot of expansion ports and everything else. The speed is good. You have processors with quad core, with dual core, so they are following the current technology. But probably some of you heard about Exynos platform. It's developed by Samsung because they used the Qualcomm processors, and then they decided to develop their own architecture. So if you're not going this way as an IMX, you also have some other options like the Odroid XU4 board from Odroid. that's the company. So we can say that you have several possibilities, and it's not like 10, 15 years ago that if you would like to build something, it was really hard to get, and it was pricey and everything. So all of these development boards and all of this hardware is getting cheaper day by day. Okay, so you got your hardware, you took some development board. Maybe in the meantime, if this is something, some bigger project, you already started developing your hardware. Next thing, when you have the hardware, is to boot your device. So booting the device, the first boot, is one of the tricky things, and I can say that if you resolve that, I'm now just speaking the custom hardware. So if you're running on the development board, you will use their example bootloader kernel, Android. They will supply you with some code to run with the demo images and everything. But if you're making your custom hardware and you got it and you want to start it, I can tell you that probably the most effort that you will invest while doing your project will be to first boot the device. And that's why I said that the best way is to go with, if you base your device on a development board, and that was my advice. If not, if you have some difficult specification, some very custom thingy, you can go all the way from the beginning. But if you base your device on a development board, the best way is to use their code. They will give you the source code. They are not closed. Development board is for the developers. So you will use their code and start from there. So everything should be done on the code of the board. And if you go from the scratch and say, okay, I'm not going to use their code, because sometimes they can be like a lot of things done, developed by open source, so you do not like too much code in it. It depends all the stuff they added. If they are clogging your device, you want it to run smooth, to run fast and everything else. So you may decide to go from scratch, but you will probably end losing a lot of hours making the clean bootloader, the clean kernel, the clean Android to start. So the advice is to go with the support packages you get from the manufacturer. In order to run any of operating systems on your hardware, you must have some kind of bootloader. So something must run your OS, either if it's Android or if it's some other free RTOS, or Ubuntu, as somebody mentioned. So you need to have a bootloader, and in our case, for the Android and especially for the IMX platform, the bootloader is called U-Boot, and it's one of the popular bootloaders, and it's developed by the open source. So you have a lot of resources, mailing list, where you can ask some questions if you are stuck, if you cannot make it work. So if you changed some components on your board, so you did not make it the same as the development board, that's where it's going to trick you and to take you a lot of time. And that's why I say it's difficult to first boot. So when you get the device and you use the bootloader and try to run it, usually you do not have any output to see if it's working. So even with this board, as you have the LCD and everything else. So for example, if this is your custom device, it's not a development board, and you try to run your bootloader, you upload it either with some ways that you prepared, you will get nothing. And that's why the tricky part is to run it, because you do not have a lot of debugging tools and everything else. So for example, one of the things that we used while bootloading, while making it work, we had one LED diode on the board, so we used that as a debugging tool. So if it's working, some part of the code, we put, okay, turn on the LED, and we see, okay, the code progressed by this point, so something is working. So if you change the specs of the development board, you change some pins, you change some key components or stuff like that, probably you will not boot the bootloader initially. And that's the something that you can say. For example, if you successfully booted your device, you can say, okay, I have done 50%. Of course, a long way is until the end of complete device that will be in the production, but you resolved one of the efforts that's maybe the biggest. When you resolve this, when you get the output of the device, so you have some kind of, for example, the console output, if you do not have the screen or something, you will have maybe the serial output, and you can interact with the device. Then you are ready to boot. You're ready to boot any OS. In our case of the Android, we have the kernel, so the next natural thing would be to tell the bootloader to boot the kernel. But before switching to the kernel and going all the other parts, you should consider a little bit about which hardware you need in the bootloader time. So, for example, all of our phones that we have, when you press the power button and it's turning on, you see on the screen like a boot logo or something like that. So maybe you will have a need for some hardware working even in bootloader time. So you should spend a little bit time implementing, writing some drivers, adapting your bootloader to support the hardware that you need in the boot time. And it will be, of course, clever to do that. As for example, I can tell you that the client that we work for creating this device wanted the boot logo to show as early as possible. So while you're pressing the device, I think the delay for turning on the device was 3 seconds or something like that. But because the screen was not initialized in bootloader at that time, but later the boot logo came like 5 or 6 seconds after pressing the button. And the product owners of the device were asking to make it work immediately when the device starts, because it's a bad UX to the users, because they will think, okay, I'm holding the button and nothing happens. So these are all the points that you should think about when going the way for a custom device. You cannot only think about the hardware and what you think you need, but you need to think about the users. So how will they feel using your device? And day by day, also, I can see in the IT industry that UX is more important, maybe sometimes even more important than development. If the user doesn't like what you've done, it doesn't matter if you've done excellent development and testing and everything, but if it's a bad UX, then you got nothing. So, as I was explaining this for the hard way to boot your device, I just wanted to show you. I'm sorry, just to go to the next screen. I just want to show you. So for the U-boot, I mentioned as one of the popular bootloader. This is their README file and their porting guide, where they made a little joke. So if you are familiar with C, you could follow a little bit, but I'll explain just a little bit of that. So they said here it's a main function, and I'll explain this alarm. But first of all, they say if available money is more than available manpower, then pay a consultant to port U-boot. So if you have a lot of money and you do not have a lot of people, if you are working on your device alone, or you are a small startup and you have several people that are working a lot of things, then do not waste your time developing bootloader yourself, but pay somebody else to do it. And for example, there is an alarm that they connected to a function, and it says project deadline minus the second 3 weeks. So if the deadline of the project is like 3 weeks or less, then it signals no more time, and here says in the function no more time, hire a guru. So if you are really near the deadline and you don't have everything working, then find somebody who is expert in bootloaders, in custom devices, in Android, whatever you need, and pay them to resolve your problem. This is just one interesting thing from the documentation. So just to show you that I'm not speaking this only on my own experience, but a lot of people, even the developers of the bootloader, are saying that. Okay, so we finished with the bootloader. We successfully booted our device. We have some kind of the console, the output on the screen. We know it's working. Next thing is to go to the kernel. In our case of the Android device, of course. And the kernel is the core of your hardware. So if you are thinking, okay, what is controlling my hardware? What is turning on the LED? What is getting my button pressed when I press the button on the device? That's the kernel. All of the physical layer is implemented in kernel, and for example, Android usually doesn't know about it. So the Android is our higher layer, which doesn't know about what happens in low level, and the kernel is the place for that. So for versions of the kernel before 3.4, they were using the board file for binding, describing all the pins you have. You have the processor, of course, and all the peripherals are connected to the input-output pins of the CPU, probably, and on some protocols or something like that. And all of this stuff you need to describe in the kernel. So in the case of 3.4 and before versions, you will use a board file. And the later kernels are using some kind of, if somebody is familiar with Linux, it's called the device tree. It's basically, they had a lot of confusion, and because there is a variety of hardware that needs to be supported in Linux, they had a problem that even every time some new board or some new CPU is supported, they needed to update the Linux kernel and the Linux distributions, and they switched to the device tree. That's another way to describe the hardware. It's something where you're connecting the nodes for your components and then describing them, like what functions to call when something happens or something like that. But we'll not go deep into that. That can be for some other talk and more technical things. And also basic configuration of the hardware. So the speed of the processor, the power management, the input-outputs like the button, the LCD, everything of this stuff is configured in the kernel. And you need to do that. You need to go that way and configure it for your own device, whatever it's your preference. And usually, if you go custom device, you will add some custom peripherals. So if you want just the peripherals you have on the development board, then, as I said, you should not consider doing a custom device, but you should buy something that will suit your need. Maybe this is too big, but you will find also another board that is smaller and that can fit your device. But if you have some peripherals that are not supported here, that are not on this board and on other boards that you can find, then you will probably add it to your hardware. And for all custom components that you have added on your device, you will have to either integrate into the kernel the driver that will be supplied by the manufacturer in some cases, and if you use something really custom and make it your own, then you will probably have to write your own driver. So you should consider that if this is a project or something, if you're not a Linux kernel developer, then you will probably need some guy or some team that will work on the kernel itself. I think that nothing special needs to be told about the kernel right now, so we end up with Android. You have resolved all the problems, bootloader, the kernel, implemented all the drivers, you have done everything, and now goes the part that you were waiting from the start. when you switch to creating your own device. So you get to boot the OS you chose, in this case Android, and you get to feel how it works on your device. So when going with Android, you can always choose, because we explained that Android is open source and everybody knows that, but you can always go to the Google website and find the source code of the Android. And even if you made your custom device and you probably want to have some optimized Android version, and the manufacturer will supply you with their own version of Android, which is tweaked, customized for the hardware, you can always set that aside and go with the plain Android. But probably you will have some difficulties making, for example, graphics or some other thing, making it work flawlessly. And that's something that the manufacturer of the development board also done in the past. So my advice is better go with Android supplied by manufacturer than going with vanilla Android. But this is your choice. The supplier will give you the BSP, board support package, and you can apply it. Usually download the Android source code, apply the BSP, and that kind of Android can be built, and then you will get your image that will put on the device and run it. So if everything before that I spoke about before has done with success, you initialize the kernel, the bootloader, booted the kernel, configure all the components, then you will get the Android booting out of the box. So you will run the Android and see it on your device. Wow, it's working, I can use it. Of course, as I said, with the development of your project before the hardware, also one thing to consider is to start developing the applications that you will use on your device, the specific application for your project need. You should start development also in parallel with the hardware. And for those needs, you can use either emulators that you have from Google also. There are some third-party emulators that are working very good, even sometimes better than phones itself. So I can just tell you there is I think it's called Genymotion, one of Android emulator that while we developed the Ray, we saw that Genymotion is like very good emulator, and even if we use the phones to try it, we sometimes added running it even on Genymotion. So you should consider start development right away, because it's a long way, and you should do things in parallel. And you will spec probably the Android version which you're going to use in the beginning. For example, we are making a device. We can either go with the current version. For example, now it's Marshmallow, or we can go with the lower version if our hardware is weaker, or if we do not need a lot of features and options that the newer Androids are supplying us. So when you choose your Android, which is going to be the target OS, you can either use the emulator for that version or phone with that version, and start the development of applications immediately. Probably why you chose the going custom device would be usually because you want also a custom Android. I mean, either if you chose some existing platform, so you're not making your own hardware, but you want to run Android and to do it your way. You do not want how it's done on the phones. You want to change something. Maybe you want to change Android completely and maybe make your own OS. Doesn't matter. But you will probably want to customize your Android. So you can customize the applications that comes with your system image by default. You can customize the look of the Android. You can change the system UI. Usually on the phones, the thing with a notification bar, with a status bar, and navigation buttons, home, back. So you can put your own. That is something that Android gives you the option. So that is another answer why is Android good OS for your hardware, because it's very flexible, it's open source, and you can change a lot of things. In our case, we have changed the system UI. For example, we have completely removed applications that we do not want on the device, so that they are also not using the storage memory, they are not run in the background with some services, so you want to make a lighter device, something like that. So this is a good thing about Android, and it gives you this possibility. When adding custom peripherals, one of the things you should think about would be, okay, so we added something. For example, let's use an example that's really basic. So you have added another diode or something like that for your hardware. So you will not want that your developers access the hardware directly, because that can draw to some really bad situations, some race conditions, something that both applications want to use the hardware, and you do not want to let them do it. So another thing that you should think about, and you should plan it in the development, would be to create the API or the SDK. If you have a lot of developers working, then it's a more clever thing to give them the SDK. But if this is something smaller, you are working on or several people, 2 or 3 people are working on that, maybe you will just create some API call, so that the Android developers, the Java developers, doesn't have to know C or how it works underneath. As I mentioned, Android will not be aware of how it works on the physical layer. So the good thing would be to create services in Android that will communicate with the kernel, and that will, for example, in this case, turn the LED on and off, and the developer would not have to go to the kernel to open some file descriptor or something that's controlling the LED. And in our case, we had this this situation. That's why I'm mentioning it, because basically developers were opening the file which was controlling the LED and turning it off and on, and then we had sometimes situations that several things wanted to flash the diode, and it looked like crap. But this is the way you solve it, is to make some higher layer, some service that will be only the one that controls the hardware, and the developers will talk to the service. So this is another point that you should think about when creating your own hardware. The last thing that can catch you with Android is, we all know with our phones we have updates. Another new version gets out of the Android. Some bugs were fixed by the manufacturer, and similar things. And you do not want to end up with releasing your device to the users and not be able to fix something if you released the wrong version, or to even update the device to push in more features, to even upgrade the Android version or whatever you want. So be prepared to think that way. So it's a one critical point of creating your device, because you can end up with screwing something, and if you are in the production and everything else, it will cost you a lot, and it's a point that should maybe even use like 20% of your time in the project planning, so that you prepare yourself for updates, for catastrophes and everything. So think also about firmware updates and new versions when developing it. Okay, so this was basically a brief talk. What will you see on the way going custom, and what are the challenges? Maybe some small, some big challenges that will be on the way. I would now just like to show you how it was while I was working on Ray, because all the experience I have from Android development and everything, I've gained working on this device. So before this, I had no experience in Android, even with developing basic application for Android. So this can also be one of things you should consider. So if you haven't done any Android development, if you don't know Android, it doesn't mean it's not for you. So it doesn't mean that you cannot easily get in and figure out how things work and develop something your own. So I thought in the presentation, should I mention this device? And I do not want to make a commercial of that for the device, but I want to show you some interesting things we done and some interesting challenges that faced us while doing it. So on the next slide here, you can see this is the Ray device that I mentioned. This is basically a device that should replace a bunch of remotes that you have. Especially the target of this device is America. And in America, they have like a lot of cable providers. They have a lot of devices in their homes, audio receivers, televisions, cable boxes, and other stuff. Of course, for example, the heating systems and everything. So even a little bit of home automation was touched by this. And the idea of the CEO of Ray was to create a device which will replace all the remotes that you have on the table, and you will not have to look, okay, where is the remote for climate, where is for TV, where is for cable box. And also it wanted to bring closer the television content to your chair. So probably some of you, if you're from Serbia, you have maybe SBB or some other cable provider, and you know that they have now some digital contents, like they have the D3 on the SBB, and you have the EPG, and on other cable systems you also have some kind of EPG, so you can look what's on television right now, what can you look in the future, replay some shows or something. So probably if some of you use this this system, you saw that UX with that is terrible. For me, myself, the UX is terrible. You press the button on the remote, then you have the delay until it switches to something else, because the cable boxes are not advanced devices, and they're not powerful devices, something like that. So it would be better to have something like we have on the phones. We are browsing Facebook, other applications and everything. So it would be easier to have something in your hand. You can look, scroll, okay, on this television, on this channel, now it's showing, I don't know, Castle or some show that I like to watch. So it's easier to have it on your side and to be able to control the cable boxes, the TV from your chair, and from that point from the point, for example, also of reminders, you can set the reminders and something else. So before the demo thing, I brought with myself two Ray devices. It's a development device. I will give you just as I speak, so that you can look at them, circle them between people. So here we are. So basically, the device that we made was custom device. So I will address first the point, why did we go custom device? And that is something that we also spoke in between colleagues. We have a different opinion. One of them have the opinion we shouldn't go custom. The other one, we were meant to go custom or something like that. But the thing is, you all know that you have phones on the market that have infrared infrared capability. One of the points to create a custom device and not use some existing platform like phone with infrared was that people in their homes or whatever, they want to see the remote. And people are used to remotes like old ones with buttons, the layout of the remote, the physical look, and they do not want to end up with using the phone. So we also had an idea not to create the device itself at all, but just to create the application so that you can use it on your phone. And you probably know there are several applications for that right now that turn your phone into the remote control. But if somebody of you tried that, you saw that you do not want to have the mobile phone as a remote control for your multimedia system, television, or whatever. You usually keep the mobile phone in your pocket. So you do not want everybody from the home, like the kids, your wife, your friend, to take your phone. Maybe you got some message or something. So the decision to create a custom device, not to go with the application, was natural, in one way. The architecture of Ray device is basically we chose Freescale IMAX platform that I mentioned before, and it's a complete platform. We were able to do all that we wanted on that one. So it has the CPU with the dual core. I'll just describe a little bit the hardware. It has a dual core CPU. It has 1 gig of RAM. It has a custom casing, so and the LCD to have a look of a remote. And it has some physical buttons on the side for turning the volume up and down and the mute, because that is one of the actions that you usually do with your remote. You turn the volume up and down, you mute, or you change the channels. We also put multiple IR diodes to get better user experience with the remote. So you will not have to use it like a standard way to point it to the television because, for example, I will use just the phone as a remote. But if you're looking at something and scrolling, then you want to, for example, change the channel, it's a bad UX that you need to push it down to point it to some device. So the device has a lot of infrared diodes around the casing, so you can use it in either way, pointing in any direction, and probably it will reach your designated hardware. So to address why have I put Ray in this presentation, I want to show you some of the interesting challenges that we faced while developing it. So from the firmware side, not the application side and developing the application, I will describe you one of the problem we had, and this was the request from the client. So Android devices usually, when they are not used, they go to sleep. And because you have the remote control, the device that is remote control, you want to have the best battery life you can. So you do not want to end up with charging the device all the time. So as our old remote controls can last like 6 months or, I don't know, a year without changing the battery. Of course, in this case, this is not possible. But you want to have the device be in a standby mode as long as possible. So when the device is in sleep, the first thing that the customer said that was a bad user experience was that you need to turn it on, and then you can use, for example, to put the volume down, to mute. Somebody's calling you, you want to mute, so you need to power it on, press the power button, and then to wake it, and then to use it. And they wanted to be able to press the volume buttons on the side without waking the Android, so that it work in the background, and that the press itself doesn't wake the device, because maybe you just want to put the volume down, you don't want to use the device, you just want to turn on, mute, volume down, whatever. And this was one of the difficult parts on Android because of its power management, as you have in Android to set some button to be a wake button. So if you press, for example, on this phone, you press home, it will wake. But to get to the point that you press the button and the device doesn't wake, but it do the job, was a little bit tricky. And one of the things that was the most difficult, so we managed to do that because Android, every time you press some button, even if it's not waking, it wakes a little bit just to check if the button is set for waking. If not, then goes to sleep. And in this way, we made, let's say, a mode for a partial wake. But the problem was that if you press the button and hold it, the Android itself will create you events like you're holding button, so your application will receive in the end events like button press, button press, button press. It will repeat for you. But the thing was that in our case, when we tried that, we pressed when device was in sleep and we pressed the volume button and hold it, only one event was reaching our application. So we were like, what's going on? Why only one? And we thought it was a problem with the Android power management, how it works, that it doesn't have some services that will create the repeatable events of the button press. But we were wrong. The point was that in Linux kernel, in the core part of the Linux kernel, for the input section, there was one comment that we also laughed about. One comment for the resume function. So when kernel is waking up on the input resume function, it said, okay, I'm waking up. I suppose that no buttons are pressed, so I reset all the states to 0 for the input pins. And that was where our problem was lying in the core of the input Linux kernel. So while working on this, you can see that different challenges can catch you, and you don't have only to work on developing your applications, and that will be the most of the time. But you will face some weird bugs or some weird behaviors that you do not want. Another interesting thing was to, as I mentioned, the battery life was to minimize the battery consumption of the device. So basically, as I explained you, the hardware was something similar for Samsung Galaxy Nexus. Galaxy Nexus, the third generation, I think, of the Nexus, has like dual core and has 1 gig of RAM, and the platform is something similar to Samsung Nexus. We tested our device with the Galaxy Nexus, and we saw that standby time for our device versus the Galaxy Nexus was half. We dig deep to see what's going on, why we have a lower battery life, and we ended up trying to optimize all of the components. So everything that is not used, turn it off, so that it doesn't waste battery life and current, and try to redesign the hardware a little bit, so they remove some components that are unnecessary using the power and some other stuff. So you can also end up going deep into the hardware to resolve one of your problems. We customize the recovery process of Android. Probably some of you know Android recovery. It's yeah.
Sorry for interruption.
Yeah, of course.
What is the battery life in production unit now?
Now it is rated to 7 days of standby time. So if you put the device on the table and leave it there, it should probably last 7 days. And for example, we didn't reach even now we didn't reach the Galaxy Nexus standby time that's more than 7 days, but that's also something that you need to go into the hardware side and maybe redesign something that was in the beginning designed bad way. one interesting thing when you mentioned this that I forgot to mention in the presentation is where you are going to develop your device. So you have a possibility to develop it by yourself if you are expert in electronics and hardware design and everything, and you know the electronic houses or factories that can create you the hardware. But you can also outsource your hardware, so make it somebody else do it for you. So this is the case in Ray. That Ray started as a startup project, and we chose, for example, ZTE to be our vendor manufacturer of the hardware. So to answer your question about the battery life and everything, we think that one of the bad decisions was to give ZTE the power to design our hardware. We should only choose them to produce it, and we should probably do our design internally. But when you're starting as a startup, you probably are not expert in that, so you go to somebody that is an expert, and the higher management chose ZTE, and you give them the power you basically outsource it. You outsource it. So sometimes it can be a bad thing, sometimes it can be a good thing, it can speed you up. And I can just, because the time is almost at the end, I don't know, do we have a Q&A time after this, or we broke that? Okay. So I'm not going to speak about other challenges or something, but just to say that it's really interesting, and you can do a lot of interesting things while developing it. So we broke the time, but if you have any questions, go now.
Is there an airborne support on the Ray? I'm sorry to hijack the topic of the device.
Currently not. So basically the device is meant to be used in your hand and everything. But one of things that I mentioned here that I didn't catch the time to say, we made an integration with Amazon Alexa. It's Amazon Echo, probably some of you know it. So probably the software will be released soon with Alexa support. So it's one of interesting things that you can say Alexa to do something on Ray. So for example, Alexa tell Ray to switch on CNN, and Alexa will communicate with Ray with some kind of push notifications and turn your channel on the TV. So it's becoming a really interesting product. Any more questions? Do I have maybe a minute of time or something?
I think you broke.
Okay. Okay. I wanted to show you the demo how the board works, but basically
Let's do it anyway.
I spoke too much. So if you're interested, you can find me somewhere. I can explain you more, because there is a lot to speak about this topic and more technical stuff. So if somebody is interested, I can fill you in and tell you everything you need to know. Thank you, and I hope I reach somebody of you maybe to even look at this, or maybe try making your own device.